Good morning, everyone. Today we are going to discuss rigid body dynamics. The very first question is, what is rigid body? Assume that you have a random shaped body, and on this one body, if the distance between any randomly picked 2 points is going to be fixed with time, means if we are taking a point A and B, if distance between A and B is not changing with time, in that case we can say this one body as the rigid body. And if distance between A and B is changing with time, in that case we cannot say this one body as the rigid body. So what is the rigid body? A rigid body is a body in such a way that distance between any two random point is not changing with time, then this one body will be called as rigid body. As for examples, assume that you have this one random set body. You are taking 3 points this time: A, next point is B, and next point is C. If distance between A and B is distance between A and B is RAB, if distance between A and C is RAC, and distance between B and C is RBC. If this one distance is fixed, in that case we will call this one body as a rigid body. I think this is clear to you. Take next examples. Assume we have a spring block systems. There is a spring connected with two blocks, namely A and B. If we have given a velocity VA to block A and VB to block B, right? If in first case velocity of A is equal to velocity of B, that is case 1, velocity of A is equal to velocity of B, it means with times distance between A and B is not going to change. Obviously, if both will have the same velocity, in that case in limit time interval both will travel the same distance, means distance between A and B is not going to change. In that case we will call this one system as rigid body. System will be called as rigid body. In other case, assume that velocity of A is not equal to B, that is case 2. In this we are taking velocity of A is not equal to velocity of B. Then what will happen? Might be B will travel some another distance, A will travel some distance. In that case, it will happen that distance traveled by A will not be equal to distance traveled by B. Then what will happen? There will be some separation with times, or there will be some distance difference between, there will be some distance difference with times. In that case, what will happen? Then we cannot say this one body as the rigid body. It means if velocity of A is not equal to B, then with time their distance will change. And if distance is changing, in that case we cannot say this one body as the rigid body. Then system, that is a spring block, spring plus block, will not be rigid body. Rigid body. Let us clarify it more. Take another examples. Assume that you have a circular ring. With it there are 3 bid: bid 1, bid 2 and bid 3, right? Assume that bid 1 has an angular velocity omega 1, bid 2 has angular velocity omega 1, and bid 3 has angular velocity omega 3, right? Two bid has same angular velocity and bid 3 has different angular velocity. It means if you will observe this, then what will happen? For bid 1 and 2, for bid 1 and 2, what will happen? With time, they will cover the equal angular displacement. And if they are covering the equal angular displacement, it means the distance between 1 and 2 will remain fixed. That is not going to change. And if the distance between bid 1 and bid 2 is not going to change with times, then we can easily call this one as the bid 1 plus bid 2 system as the rigid body. As distance between bid 1 and 2 not changing, then system, that is bid 1 plus bid 2, is called as rigid body. Rigid body. What if we will take in our system as bid 1 and bid 3? If we are taking bid 1 and bid 3 in our system, then what will happen here? Bid 3 will move with different angular velocity. Bid 1 will move with different angular velocity. In that case, what will happen? There will be some separation with times. And if there is separation with time, then what will happen? Then according to our definitions, we cannot say system of bid 1 and bid 3 as the rigid body. I think this is clear to you. What is the meaning of rigid body, right? For bid 1 and 3, for bid 1 and 3, as omega is different, so as omega is different, so it is not a rigid body. I hope by this we clear the concept of rigid body, when it is called to be a rigid body and when the system will not be called as the rigid body. Let us see some properties of rigid body. The very first one properties of rigid body is, in a rigid body, if we are taking any two random point, any randomly point, in that case, velocity of approach or separations. It means if our rigid body is moving with different velocity, assume that velocity of A is VA, this side, and this one VA is making an angle of theta A to the line joining A and B. Velocity of V is taken as VB, and this one VB is making an angle of theta V with the line joining A and B. In that case, if it is a rigid body, then velocity of approach or separations of the point A and B will be 0. It means if we have a rigid body and that one rigid body is moving and every point has the different velocity, in that case, in case of rigid body, velocity of approach or separation of any point will be 0. It means if we have to write velocity of approach, then what will write? VA cos theta A minus VB cos theta B. Because when we are talking about the approach or separations, we used to take the component of velocity along the line joining A and B. So VA cos theta A minus BV cos theta B must be 0. And if it is 0, then and only then the body will be called as rigid body. Or in converse, we can say that if it is rigid body, then VA cos theta A minus BB cos theta B will be 0. From here we are getting VA cos theta A must be equal to VB cos theta B. This is the properties of rigid body. This is the important property. This is the first one. Second, velocity of separation is also 0. By the same way, velocity of separation will be zero. Velocity of approach as well as velocity of separation will be zero. This is the very first and important properties of rigid body dynamic. Let us see the second one property. If we have a rigid body and that one body is moving, in that case, if you are going to observe any point of the rigid body with respect to the another point of rigid body, another point of same rigid body, in that case, the motion of the B will be observed as the circular motion. I mean, assume that this body is moving and every point will have the different velocity. If you sit on any point of the rigid body, then the other point will looks like moving in a circular motions. Other points will look like moving in a circular motions. Will perform a circular motions as seen from the other point of the same body. I think this is clear to you. And if it is performing a circular motions, it must have a angular speed. So what will be the angular speed? Assume that this is the line joining A and B and the distance between A and B is RAB. RAB. At any times, it is given that the velocity of B is VB and the velocity vector making an angle of theta B with the line joining AB. By the same times, velocity of A is given as VA and this is making an angle theta A with the line joining A and B. If we have to find out the angular speed, then what will be the angular speed? We know that angular speed is nothing but the relative component of B with respect to A perpendicular to the line joining A and B. It means relative component of velocity of B with respect to A perpendicular to line joining A and B divided by distance between A and B. So what will it be? If we will talk about the perpendicular distance. So let us take the perpendicular distance. Perpendicular component of velocity. This is VA sin theta A for the point A and this will be VB sin theta B for B. So from here, if you are taking this one direction as the plus, then what will be the angular speed or angular velocity? It will be VB sin theta B minus VA sin theta A divided by RAB. This will give us the angular speed of any point with respect to any other point. Is this clear? The third one properties of a rigid body is, in a rigid body, if we are taking any random point and we are calculating it the angular velocity, in that case the angular velocity of any point with respect to any other point will be same. What does it means? Assume that if you are looking B by sitting at A and assume that its angular velocity is omega, then on the same time if we will look at C by A, then it will also looks like it is moving with an angular velocity of omega. Is this clear? Take it another examples. Same body, same 3 point is taken, A, B and C. Now the observer is not at A. Now observer wants to sit at C. And if the observer is looking A, then the A will have the same angular velocity omega in the same sense, as well as observer will look that B will also have the same angular velocity omega as seen by the observer when he was sitting on A. I think this point is clear to you. So what is this? In a rigid body, all the particles will rotate with same angular velocity. In a rigid body, all the particles will rotate with same angular velocity. If we will look on the another examples, take it as a triangles. Assume that there is point 1, point 2 and point 3. Point 1, point 2, point 3. There is one more point, that is point 4. If an object is sitting at 4, if he observed that point 1 is moving with omega, point 3 will also move with omega and point 2 will also move with omega. Now what happens? Observer switch to point 2. Now he will observe that point 4 is also moving with omega. Point 1 is again moving with omega. I think this time this is clear to you, right? As for example, assume that you have a disk and it is rotating anti-clockwise with an angular speed of omega. If we are taking any 3 point on the circumference of the disk in such a way that 1 and 2 is opposite, diametrically opposite, and 3 is here, this is also making an angle of 90 degree. If we have to find out omega of 1 with respect to 2 and have to find omega of 1 with respect to 3, the very first question is find omega of 1 with respect to 2. Then what will you do? Very first write the velocity of 1, 2 and 3. If it is rotating in anti-clockwise, then velocity of 1 will be like this. And what will be the velocity? Omega into r. Velocity of 2 will be in this directions as we know in circular motions. So what will be velocity? Omega into r. Velocity of 3 will be in this directions. What will be velocity? Omega into r. Now we have to find out omega of 1 with respect to 2. So what we'll do? We will join the position of 1 and 2. And the distance between 1 and 2 is 2r. Now omega of 1 with respect to 2 will be velocity of 1 with respect to 2 perpendicular to the line joining 1 and 2 divided by distance between 1 and 2, right? Okay. Now write it. Velocity of 1 with respect to 2 is omega r. If we will take this one direction as the plus x axis, this one direction as the plus y axis, then the velocity of 1 with respect to 2 will be velocity of 1 minus velocity of 2. Velocity of 1 minus velocity of 2 divided by r of 1 with respect to 2, right? From here we are getting what is velocity of 1 minus omega r. What is velocity of 2? Omega r. Divided by what is the distance between 1 and 2? It is 2r. What are we getting? We are getting 2 omega r divided by 2r. 2r to 2r cancel. It means velocity of angular speed of 1 or angular velocity of 1 with respect to 2 is equal to omega, right? This is the very first examples. Let us take the another examples. It means you have to find out angular velocity of 1 with respect to 3. In that case, what will you do? Again, the very first step, join the position of 1 and 3. As this is 90 degree, this is r and this is r. This is r, this is r. So this angle will be 45 degree. This angle will also be 45 degree. So what will be the distance? Root 2r, right? This distance will be root 2r. Now, according to our definitions, we have to use the perpendicular component of velocity along the line joining A and B. So what will be the perpendicular component? This one directions. This one direction of the velocity, and how much this velocity making? 45 degree. So this angle will also be 45 degree. Now tell me, this one component of velocity will be omega r cos 45 degree, right? Take its component also. This will also be, if this is 45, this angle will be 45 and this angle will also be 45 degree. So this velocity will be omega r cos 45 degree, right? Now we have to write omega of 1 with respect to 3. Omega of 1 with respect to 3. It means have to take the perpendicular component, that is omega r cos 45 degree. If we'll take this one direction as plus, then this direction will become minus, negative. Omega r cos 45 degree minus omega r cos 45 degree divided by, what is the distance? Root 2r. Root 2r. From here we are getting 2 omega r cos 45 degree divided by root 2r divided by root 2r. So what are we getting from here? Omega of 1 with respect to 3 is equal to r to r cancel. Cos 45, 2 omega cos 45 is 1 by root 2. Cos 45 1 by root 2 divided by root 2. So this one is also cancelled. We are getting omega of 1 with respect to 3 is equal to omega. So by taking these two examples, we get to know that whatever point we are taking and whatever the reference we are taking on the same rigid body, we will get the same angular speed, or we will get the same angular velocity. So this is all about your today's theory class. Let us write your homework. We will discuss this one homework in the next upcoming class, as well as in the next upcoming class we will start the motion of the rigid body. So this is your homework. Please write down it. In the very first questions, what you have to find out, if this is a rigid body, in that case you have to find out velocity of A. What is the conditions? The condition given is velocity of B is along the line joining A and B, and it is equal to 4 meter per second. Clear? In that case, if A is moving at the times at an angle of 60 degree, then you have to find out velocity of A first. In second questions, assume that you have a spring block system. Velocity of one block is given as 8 meter per second, and at the time when this one system can be called as the rigid body, in that case you have to find out velocity of A. In the third one questions, you have to find out what will be the omega when the velocity of point A is given as 8 meter per second and it is 60 degree with the line joining A and B first. Second, velocity of B is also given as 8 meter per second and the angle between line joining A and B and velocity of B is again 60 degree. Second. Third, the given condition is distance between A and B is 8 meters. So you have to solve these questions and have to bring your solutions in the next class. We will discuss this one question in the next class, as well as we will start the motion of rigid body in the next class. Thank you.